Okay, we're going to get started with the warm-up today. So this is week 5, I believe, right? Week 5 of this term, class 1 warm-up. And let me show you where I am, and I'd like you to go to the same place. We're on this 5.3 practice master. Just slide to the right, or you can slide down below, either way. We just need a little workspace, nothing too crazy. So go to that document now, and we're going to work some. You don't have last night's homework? Oh, I'm sorry. I should be on last night's homework. So let me cut this. First error of the day is out of the way. That's good. Good to knock that out. Um, Whatever. Just find any place to do it. It's fine. Doesn't have to be. There we go. Any place is fine. Okay. So here we go. Week 5, class 1 warm up. Number 1, I want you to convert 0.6 repeating. Convert that to a fraction. Everybody take a moment to convert that to a fraction now. If you're at home, pause the video and do that now. Convert that to a fraction. So let's say n is equal to our repeating decimal, everything to the right of the decimal, which is 0.6 repeating. How many digits repeat here? 1. So we're going to multiply n by 10. Notice I put it on top of the n. I do that on purpose. When we multiply by 10, that decimal moves how many spots to the right? 1 spot to the right, and we get 6.6 repeating, like that. Now what do we need to do? Subtract. 10n minus n is 9n equals this 0.6 repeating minus 0.6 repeating. That's gone. 6 minus 0 is 6. When I say it's gone, it's 0, right? We now need to divide both sides by 9 to solve for n. So we divide by 9 on the left. We divide by 9 on the right. And we get n is equal to 6/9. We can divide both of these by 3, and we get 2/3. 2/3. You should have had 2/3 for this one. 2/3. If you said 6/9, you can just make sure you simplify it next time. So rule of thumb here, when you have one digit repeating after the decimal like this, that'd be like 0.1 repeating, 0.2 repeating, 0.3 repeating, whatever. You can just throw it over 9. You don't have to show all this work. It's good to know how to do all this work, but you can know that like anytime it's just one digit to the right of the decimal repeating, and that's all it is, just throw that number over 9 and then simplify as needed. So like if you just showed me that, that would get full credit on a test or a quiz. Questions on that? Okay, let's try another one. Number 2. Number 2. How about this one? I want you to write 3.4 as a fraction. Be careful, this one does not repeat. This one does not repeat. Anybody need more time here? Okay, so on this one, 3 is to the left of the decimal. So we're going to take 3 and we're going to set it off to the side. That's going to be part of our mixed number here. 4 is in the tens place, right? So it's 4 over 10. Again, that is the tens place. Anything in the tens place, just put it over 10. We can divide both these by 2 and we get 2/5. 2/5. So it's 3 and 2/5. That's what you should have had there. 3 and 2/5. If you had 3 and 4/10, just make sure you simplify. Questions there? Okay. So number 3, 5.45 repeating. If you're at home, go ahead and pause the video, work this one now. This will take you a couple minutes, so be patient. Work the method to find a repeating decimal converted to a fraction. All right, let's take a look at this one. So 5.45 repeating, we're going to take our 5, we're going to set it off to the side. That's going to be part of our mixed number here. So 0.45 repeating, we're going to have that equal to n. So 0.45 repeating, that's equal to n. How many digits repeat here? 2. So we need to multiply by 100. We slide that decimal 2 spots to the right, and we get 45.45 repeating. You always want the repeating portions to line up, so that when you subtract, you can easily see that becomes 0, right? 0.45 forever minus 0.45 forever. We end up with 99 in on the left side is equal to 45 on the right side. We then need to divide both sides by 99. So we divide by 99, and we get 45 divided by 99. We can divide both of these by what? 3, right? Divide that by 3, divide that by 3. You don't have to show this. You can just write it equals 15 over 33. Like if you want to divide by 3 mentally, I'm okay with that. All right, what can we do here? Yeah, divide by 3 again. Divide by 3, and we get 5 over 11. So that's 5 elevenths. So 5 and 5 elevenths. There we go. Yes, Veda.
So I just since it's always if it has the bar over the last 2 digits, then it's over 99. So I just did 5 and 45 over 99, and I didn't show my work, but I have to.
That's fine. I know what you did. Here's number 4. By the way, number 3 was 5 and 5 elevenths. Here's number 4 on the warm-up, 0.56. Just recapping what we did last week, 0.56. All right, folks at home, sorry about that. I started without catching you guys up here. The 6, that's in the hundreds place, right? So we're going to put something over 100, and that's 56 over 100. We can divide 56 and 100, and we end up with, hang on a second, there we go. Okay, so we divide by 2, and we get 50 in the denominator. What's in the numerator? 28. What can we divide by here?
2.
We can divide by 2 again. And we end up with 14 over 25. Are we done? 25 we can only divide by 5, right? Can we divide 14 by 5? Nope. So we get 14 25ths on that one. 14 25ths. We good there? Okay. Kyle, did you get that one? Good. Number 5. Negative 6.124. Give that one a shot. Convert that to a simplified fraction. Okay, so for this one, we're going to take negative 6 and just kind of set it to the side. We're going to focus on everything to the right of the decimal. That 4 is in what place? The thousandths place. Because that's in the thousandths place, we're going to have a denominator of 1,000. Campbell, what needs to go in that numerator? 124. Very good. Kendall, we can divide both these by what?
2.
By 2. And we get 500 in the denominator. What's in the numerator? 62. Can we divide again?
Yeah.
What do we get? Yeah, we get 30. Ignore that. Divide by 2. And we get 31 over 250. 31 is prime. 51, we cannot, I'm sorry, 250, we cannot divide that by 31. So we're done. 31 over 250. 31 over 250. There you go. Questions on that? All right, not bad, right? Okay, again, this is all stuff we learned last week. Hopefully it's coming back to you now. For each of these, I want you to write W, I, R, or none. All that apply. So here we go. This is going to be 6, 7, 8, and 9. We'll just hit all these at one time. Number 6 is 0.32 repeating. Okay. Number 7 is going to be negative 81. Number 8 is going to be 102. And number 9 is going to be 81 83rd. So for each of these, oh, and I got one more, number 10 as well. Number 10 is 8.129452221, and then this goes on forever. All right, so try those 5 on your own. W, I, R, or none, write all that apply there. All right, Avery, that first one, what do you think?
R.
R, correct. Anything that repeats is a rational number. Anything that repeats is a rational number. You can write that as a fraction, right? Remember, rational numbers we can always write as a fraction. Number 7, what do you think there, Matthew? R and I, right? Anything that is an integer is also rational. Negative 81 is an integer, which means it's also rational. Number 8, Parker, what do you think?
Whole number, integer, and rational.
Whole number, integer, and rational. Very good. W, I, and R. Number 9, let's see, Bennett, what do you think on number 9? Okay, we'll look at it now. What do you think? It's a fraction, right? It is rational. Anything that is a fraction is rational. And it's not an integer. It's not a whole number either. Zella, what do you think about number 10?
None.
None on number 10. None on number 10.
What about 8?
What?
What about
That,
number 8?
the number 8? No, so anything that does not end and does not repeat, you cannot write as a fraction. Therefore, it's not rational. Let me give you a bonus one here, number 11. Let's do this. 0.456. 0.456. Think about that one. Could you write that as a fraction, yes or no? You could. If you can write it as a fraction, what does it have to be? Has to be rational. Has to be rational. So that one's rational. Okay? Very good. In your class notes, we have this document, 5.3 pp. We're going to talk about adding and subtracting with decimals today. If you can add or subtract, then you can add or subtract with decimals. So remember the estimating we've been doing? We're going to do that, and then we're actually going to find the exact answer. So today's properties that we have learned in the past that we're going to apply today, let's review them really quick. The commutative property. The commutative property deals with what? Starts with an O. Commutative, you should think about what word? What? Order. The order can change, right? Negative 8.1 plus 9.6 is the same thing as 9.6 plus negative 8.1. We can change the order and nothing happens to the sum, right? The associative property deals with what? Starts with a G. Groups, right? So commutative, order. Everybody say commutative. Say order. All right, everybody say associative. Say groups. Very good. So we can change our grouping here. Negative 3.5 plus 5.2 in a group plus 3.1. And now we change the group up. The order doesn't change though. Negative 3.5 plus, and now the grouping is 5.2 plus 3.1. So we can change the group. The identity property is when we add 0 to something and the sum doesn't change the number. The inverse property, we add the opposite to it and we get 0, or you can say you subtract the number from it, you get 0. So like 6 plus negative 6 is 0. 15.8 plus negative 15.8 equals 0. So all these same properties apply. So now let's go on to the practice as soon as my computer loads. Okay. Solve each equation. Estimate first to check for reasonableness. So this is where the estimation comes in handy. Let's do a quick estimate here for M. What do you think it should be? Sarah Kate.
13 plus 12.
13 plus 12. What's 13 plus 12, Sarah Kate? What?
25.
25. So 25 is our, I'm going to write in white here. It shows up on this blue better. All right, so 25 is going to be our estimate there. 25 is our estimate. So now, you guys remember when you were in like elementary school and you would line up numbers to add them? Same thing, but make sure you line up the decimals, okay? You guys with me on this? So, now we just go through it, just like you would a typical addition problem. Make sure you put plus here. 2 plus 7 is 9. Bring down the decimal. 3 plus 1 is 4. 1 plus 1 is 2. So we get 24.9. Now, is 24.9 pretty close to your estimate of 25? Yes. So do you feel confident in your answer? Yes, you should. Now, let's say you messed up with the decimal. You didn't bring the decimal down, and you got an answer of 249. This is why we do the estimate. We do the estimate because if there's a minor error that results in a wildly incorrect answer, like if you didn't bring the decimal down, you told me the answer is 249, you should look at your estimate and be like, oh, I think I messed this up. Let me go back and check my work again. Okay? Let's try this next one on our own. All right. What? Right, so that's something you should go back and check too, right? You might have messed up on the estimate, in which case you should go back and review that. You may have made a mistake there. All right, 231 minus 126.7. Remember, we want to be able to do this mentally. So what are two numbers that work together well here that allow us to subtract mentally? Beta.
230 and 125.
Let's go even simpler than that. 230 minus 130, which is 100. So this is about 100. We're going to be close to 100. So everybody take a moment now and subtract. Actually, let me help you get it set up. 231 minus 126.7. Now, notice there's nothing to the right of the decimal here, right? So what do you think we want to do? Point what? 0.0. So sometimes you have to put in that 0 to the right of the decimal to get everything to line up well. So subtract that now on your own. Give that one a shot. We have to borrow from this 1. That becomes a 0 then. That becomes a 10. What's 10 minus 7? 3. Bring down that decimal. 0 minus 6, can't do that. Got to borrow from the 3. That becomes a 2. That becomes a 10. 10 minus 6, we get 4. 2 minus 2 is 0. 2 minus 1 is 1. So we get 104.3. 104.3. Go back over here. 104.3. Is that pretty close to our estimate of 100? It is. It is pretty close to our estimate of 100. Try this next one on your own. 15.6 plus 11.2. Okay, so for my estimate, 15.6, I made that 16, plus 11.2, I made that 11. So 16 plus 11, 27. Remember, you should be able to estimate mentally. 15.6 plus 11.2, line up the decimal. 6 plus 2 is 8, bring down the decimal. 5 plus 1 is 6. 1 plus 1 is 2. So we get 26.8. Is that pretty close to our estimate? It is. Okay. This next one here, I'm going to write out our estimate. What do you want 112.9 to be? Let's make it 110. I like that, Kyle, because it's good. It's easy to work with, right? 110 is a nice round, even number. If you even wanted to make it 100, that's okay. I would not make it 113. Minus 238. All right, who can tell me what is 110 minus 238? Raise your hand if you think you know. Taylor?
128.
Nope. Parker?
-100.
Negative 128. So there's your estimate, negative 128. Remember when we subtract, everybody, 8 minus 3 is what? 5. So what is 3 minus 8? Negative 5. The number that has the larger absolute value, that is the sign of the difference, okay? Okay. We're going to stop there. We're out of time. No homework tonight. If you're at home, hope you have a great day. We'll see you next time. Take care.